right, so last time we talked about how to solve a quadratic equation using factoring. And the other major method that we're going to use is called the quadratic formula, although we won't get to that until next time. Before we do that, there is this other method that can be pretty useful when you don't have a linear term in your quadratic. So for instance, if we have something like, I don't know, 3x squared plus 2 equals 0, or something like that, where we don't have an x in there. We did have, when we were factoring, a technique called completing the square that we used when things were in this form, but completing the square really only is useful if both terms are perfect squares. So that difference of two squares could have worked for, if you have something like 4x squared minus 25 equals 0, you could factor this as 2x plus 5 and 2x minus 5 using that difference of two squares technique. But if those two terms are not perfect squares, then this is really not going to be an advisable way to solve this. And so I'm going to give you another method here for solving quadratics, but this is only going to work if you don't have a linear term. So you don't have like a 2x or something like that in the equation. So this method is going to require that we use something called a square root. And so I just want to remind you what that means. Okay, when you multiply something by itself, we have this notation called exponentiation, where you raise something to an exponent. Right? So if you see something like 3 squared, what that means is 3 times 3, and that would equal 9. And so the square root symbol is, instead of raising something to the second power, means we're raising it to the 1/2 power. And we're essentially doing the opposite of squaring. So if I ask you, what's the square root of 9? The answer is 3. Okay, so this symbol of the square root symbol is going to be helpful in solving some of these equations. So let's take a look at some real basic ones, and then we'll move into some more complicated ones. So let's say we have x squared equals 9. So the question that's being asked here is, what number squared is 9, right? And, if you look back at what we wrote before, you might think, oh, it's just 3. 3 squared is 9, that works. But there's actually another solution as well. There's another number that when you squared it equals 9, and that's -3. So where the -3 comes from is when we go to solve this, to undo this x squared, we want to do its inverse operation, which is the square root. Okay, so just to be clear here, the square root of x squared is actually going to equal the absolute value of x. And the reason why it's not just x is because whether or not you're going to plug in a positive or negative number here into x, when you square it, it changes it to be positive anyway. And that's what allows us to do this whole square root thing. So for this equation, we're going to take the square root of both sides. So we'll have the square root of x squared equals the square root of 9. And when you take the square root of x squared, we get the absolute value of x equals 3. Now the absolute value, this is a function that whatever you substitute into x will make it positive, right? So there are two numbers that we could plug in here that would make this equal to 3. The absolute value of 3 is 3, and the absolute value of -3 is also 3. So we actually end up with two solutions here. We get x could either be positive or -3. Now, you might eventually, when you start to get the hang of this technique, kind of just skip over this whole absolute value step. If you just remember that, hey, a quadratic in this form, like x squared equals a positive number or even a negative number, is going to have two solutions. It's always going to be plus or minus whatever that square root is. But I just want to make sure you understand that the plus or minus is not coming from square rooting the 9. You don't get a plus or minus out of that. Where the plus minus comes from is taking the square root of x squared. Okay. So just want to be clear about that. It's really kind of a nuanced point there that may not even really bother you, but I just want to make sure you understand that. So let's do another one. x squared equals 36. You might already know what the answer is going to be here. You're thinking what number times itself is 36? It's 6, right? But let's show the work here. The square root of x squared should equal the square root of 36. And so the square root of x squared is going to be the absolute value of x. And the square root of 36 is 6. So we get the absolute value of 6 is, or the absolute value of x is 6. So x could either be plus or minus 6. Now, like I was saying before, eventually I want you to be able to just go basically straight from the question to the answer here, right? If you ask yourself, what values squared give me 36, I would hope that eventually you get to a point where you just know what the square root of 36 is and know it could be plus or minus and just go straight to the answer. But this is how we're getting there. This is sort of like the behind the scenes of logically where those numbers come from. Now, these are pretty straightforward equations, right? But sometimes it's going to be you're going to get some weird ones. Like, how do we deal with square roots of negative numbers? Right? This is something that doesn't come up too much. You might remember in Algebra 2, it may have come up once or twice, but it's not something that's very common. In fact, up until Algebra 2, most of your math teachers probably told you that you cannot take the square root of a negative number. There is no answer, but there is. Okay, so I'm going to try to explain what that answer would be. Now, we would solve this just like we did the one before, right? Take the square root of both sides. Oh, where'd it go? There it goes. So take the square root of x squared and the square root of negative 9. The square root of x squared is still absolute value of x. But the real question is, what's the square root of negative 9? This is kind of a hard question to answer. Do you think you have an idea? What number times itself would be negative 9? Because 3 times itself is 9, but negative 3 times itself is also positive 9. This is kind of a tough question to answer. Yeah, what number times itself is negative 9? Now, the answer here is not going to be very satisfying, I think. But I think I can get you all to a point where you will see what the answer is. Okay, so let's see if we can do a little pattern recognition here. So what I want you to do is in your head, try to calculate these values. What is the square root of 4 squared? All right, let's see if you can come up with that. The square root of 4 squared. Well, what's 4 squared? Yeah, that's 16. And what's the square root of 16? Don't think too hard. 4, yeah, 4. Okay, very good. So the square root of 4 squared is 4. What's the square root of, I don't know, 9 squared? All right, well, 9 squared is 81, and the square root of 81 is 9. Okay, we could keep this pattern going. The square root of, let's say, 100 squared. Ooh, this one might be a little hard to do 100 squared in your head, but what you could do is the square root of 100 squared. Square root of 100 is 10, and 10 squared is 100. The square root and the square, doesn't really matter what order you do those in. You could do the square root first, or you could do the square first. So for instance, like square root of 4 squared, you can think of that as the square root of 4, quantity squared. Or the next one, the square root of 9, quantity squared. Or the square root of 100, quantity squared. So let's think about, hopefully you're seeing this pattern here, right? So the square root of negative 9 squared should be, if we're following this pattern, right? The square root of 4 squared is 4, square root of 9 squared is 9, square root of 100 squared is 100. So the square root of negative 9 squared is negative 9. And so we see now, hopefully you see, that there is a number that if you square it, you get negative 9. And that number is the square root of negative 9. Yeah, kind of silly. So yeah, it's kind of a, what's the square root of negative 9? Oh, it's the square root of negative 9. Yeah. It's actually not a number on the number line. It's off the number line, off the grid. And so because it's not what we call a real number, we have like a whole different way of categorizing these kinds of numbers when you have square roots of negatives. And so this is something that you may or may not remember from Algebra 2, but the square root of negative 1, which is just itself, right? Like there's not a number on the number line that you can square to get negative 1, but you could square the square root of negative 1 to get negative 1. It's kind of annoying to have to it sounds like we've got sort of circular reasoning going on here, but let's give whatever this number equals a name. We're going to call it I. And the reason why we're calling it I is that it's not a real number, but rather it's an imaginary number. So not imaginary like in English, it doesn't mean like it doesn't exist. So it's a little different. Its mathematical definition just means that it's not real. And again, real in mathematics isn't the same thing as real in like English. Doesn't mean like exists or not. It's just a classification of a type of number. Okay, so the absolute value of x equals the square root of negative 9. It's not very satisfying, but we can break this down a little bit because we could take the square root of 9, right? We know the square root of 9 is 3. And so what we can do is we can say x equals plus or minus the square root of 9 times the square root of negative 1. Right? Because 9 times negative 1 is negative 9. And we know the square root of 9. It's 3. So x is going to be plus or minus 3 times the square root of negative 1, which we're going to call I. So anytime you ever see I, that just means the square root of negative 1. So these numbers are not numbers that are on the number line. You can't say like, oh, this is bigger than 2 or smaller than 2. It's not even on the same number line as 2. It's way off. It's like it's in another dimension is what it is. Okay. There is a way how you can represent this on a grid, but you would have to be like above or below the number line to really properly represent it, not on the number line, which is kind of weird, but that's what it is. All right, these are not going to be very common, by the way, if you're feeling a little anxious about these kind of problems. They'll come up from time to time, but they're not going to be super common. So let's do one more of these negative square roots. So we've got x squared equals negative 25. So first, I'm going to take the square root of x squared and the square root of negative 25. The square root of x squared is the absolute value of x. And we can rewrite square root of negative 25 as the square root of 25 times the square root of negative 1. Basically, what we're doing is factoring out that negative 1 because that's what's causing really all the problems here, right? It's a little bit of a problem child, that square root of negative 1. Okay, so the absolute value of x is just going to be plus or minus x. So x will be plus or minus the square root of 25 is 5, and the square root of negative 1 is I. So really, like if you're looking for a shortcut here, if you take the square root of a negative number, you're going to have the plus or minus when we're solving here, but you could just take the positive version of that number, square root that. The square root of 25 is 5. And then if it's negative, just slap on an I at the end. It's going to be the shorter way of approaching this. Okay, so that's how we deal with the negative numbers. Now, most of the equations you're going to solve are going to be more like this, okay, where it's not just going to be like x squared equals 81 or something like that. There'll be a little bit more to it, but we're going to still approach it in the same way. Okay, so the only real difference here is we want to try to isolate the x squared up front. So first, we'll subtract 75 from both sides. And that'll give me negative 3x squared equals negative 75. Then we can divide both sides by negative 3. And that's going to give us x squared equals 25. And now it becomes a pretty straightforward square root problem, right? We're just going to take the square root of both sides, make sure we have that plus or minus, and x is going to be plus or minus 5. But just to show these steps, and again, these next couple of steps you can usually get away with not writing. But I really just want to show you like where all this is coming from. Yeah, make sure you have a more conceptual understanding. Okay, so the square root of x squared is the absolute value of x, and the square root of 25 is 5. So the absolute value of x is 5. That means that x could be either positive or negative 5. Now this next equation is a quadratic function. Y is a function of x. And the instructions say find the zeros. And basically what that means is set y equal to 0 and solve for x. We're looking for the x values that make y 0. The first one was kind of already set up for you. So basically we just need to replace that y with a 0 and then solve it similar to how we did the last one. This one's going to turn out a little bit different, and well, let me show you why. We'll start by adding 49 to both sides to get 49 equals 100x squared. And then if we try to divide by 100, it's not going to divide evenly. On the last one, we had 75 divided by 3, which worked out nicely. But here we have 49 over 100. That doesn't divide evenly. So we're just going to leave it as a fraction. Don't even bother trying to reduce it yet, because both 49 and 100 are perfect squares. 49 is 7 squared, and 100 is 10 squared. So when I go to take the square root of both sides, I'm really not going to have a hard time taking the square root of this fraction, because when you take the square root of a fraction, you can take the square roots of the numerator and the denominator separately. All right. So I guess first I'm just going to flip this. X squared equals 49 over 100. And now I'm going to take the square root of both sides. So the square root of this side and the square root of this side. That's going to give me the absolute value of x equals the square root of 49 is 7, and the square root of 100 is 10. So we just have 7 tenths. And then because it's the absolute value of x, we have to make sure to account for both the positive and the negative versions of 7 tenths. Right? Because the absolute value of negative 7 tenths is still 7 tenths. And both of these two values will satisfy the original equation. If you don't believe me, you can always go back and plug it in. Like if you use a calculator and you plug in negative 7 tenths here, this will equal 0. But if you plug in positive 7 tenths here, it'll still equal 0. So both of the solutions should work. Any questions so far? Good? All right, so the other kind of weird thing that can happen is sometimes like the number that you're taking the square root of is not a perfect square. In these cases, you're just going to normally just leave it as a square root and not simplify it. but sometimes you'll want to estimate it using the calculator. So I'll kind of show you how to do both of those. So both of these we'll solve similar to the last ones, but what you're going to see is we're going to end up with a square root of a non-perfect square. So for this first one, we'll subtract 40 from both sides. And have negative 2x squared equals negative 40. Then we can divide both sides by negative 2. And get x squared equals 20. Now 20 is not a perfect square. Okay, 3 squared is 9, 4 squared is 16, and 5 squared is 25. Now 20 is in between 16 and 25, so we know the square root's got to be somewhere in between 4 and 5. We just don't know exactly what. So when you go to take the square root of both sides, we are going to get like x equals plus or minus the square root of 20, but you can just leave it like that. There's your answer, the square root of 20. And if sometimes and we'll see a couple of these in just a minute here, but sometimes you'll have a word problem where there's some context built behind it and the multiple choice answers will all be in decimal form. So just make sure you know how to type that in to your calculator. So let me just see what that would be up here. Square root of 20, it's going to be about 4.47. So this is what we'll call the exact answers or solutions. And then x is approximately plus or minus 4.472. And I'm not going to be too picky about like how many decimals you go out. Really, this is just, and most of the time I won't even ask for the decimal anyway. But if it's a multiple choice question, you want to know how to put that in. That's considered the rounded answer or the approximate answer. So the square root of 20 is right around about 4.47. Oh, and it should be plus or minus. Forgot that. So there should be two answers. All right, we'll do one more like that. For this next one, we'll start by setting it equal to 0 so that we can actually find the solution. So if 0 equals negative 3x squared plus 20. If we subtract 20 from both sides, we have negative 20 equals negative 3x squared. Then we could divide both sides by negative 3, and we'll end up with a fraction here. That's okay. And I'm actually going to take this opportunity to just like flip the whole equation here. Like put the x squared in the front. So we got 20 thirds. Neither one of those are square roots. So like if you look back to the previous problem we did where we took the square root of 49 over 100, we were able to do that because both 49 and 100 are perfect squares, right? 7 squared is 49, 10 squared is 100. But here, 20 and 3, neither one of those are perfect squares. So my solutions are just going to be plus or minus the square root of 20 thirds. And you can just leave it like that. That's as precise as we can get. So this is the exact answer. And then the approximate answer, we'd have to type that in the calculator. So let's see here, 20 thirds, the square root of that. So it's approximately 2.582. And again, that should be plus or minus. So, sometimes you'll be asked for an approximate answer. Sometimes you'll be asked for the exact answer. It just kind of depends on what the problem throws at you. Any questions? All right, well, let's take a look at some contextualized problems here. This is one that's pretty similar to what you would see on the TSI, where they give you an area of a square and ask you to find the side length. Now, the TSI is multiple choice, so most of the time you can just like reverse engineer the problem. It's a lot easier to do it that way, but I still want you to know like the proper way on how you would solve this. So if we have a square and the area of the square is 300 square centimeters, the question is, what are the lengths of the sides? Now on a square, you do have to know that all the sides are the same. So we'll just call that side length x. And you also need to know how to find the area of a rectangle, which is base times height, or in this case, just x times x. So we have x times x, which is x squared, equals 300. Well, 300 is not a perfect square, so when we go to take the square root of it, we do get the plus or minus, but we're just going to leave it as root 300. And then I think most of the time on the TSI, they're going to have the rounded version. So let's just throw that in the calculator to see approximately what that is. The other thing I want you to consider here is because we have some context built around this problem, we're trying to find the side length of this square. It doesn't really make sense to have a negative side length on a square. And so in this context, we're not going to accept negative root 300 as a solution because it doesn't really make sense with the context of the problem. Algebraically, this is a solution. Negative root 300 is a solution to the equation, but the equation is really just a means to an end, a means to find that missing side length. So we get this sort of erroneous solution. So just be aware that when you're solving these, especially when you're dealing with a geometrical object, oftentimes the negative solution is just meaningless. So we're going to disregard the negative solution. Okay, so x will equal the square root of 300. That's the exact solution. And if you just box that, I'm good with that. But if we want the approximate solution, we would go to the calculator here and get the square root of 300, which is roughly 17.321. I'll just throw in centimeters also. So this is I think we've seen problems like this on the practice TSI tests we've taken. And also I think, you probably saw it on one of the TSI tests that you actually took. And maybe not, there's no guarantee on what questions you'll get. But I've had this one reported back. Yeah. Okay, let's look at one more geometry related question here. It says the length of a rectangle is 4 times the width. If the area of the rectangle is 256 units, find the length and the width of the rectangle. So let's go ahead and draw this rectangle. Now the area of a rectangle is the length times the width, right? We know that. It says the area is 250 units, and that should say units squared, like square units. So that's not really going to affect how we solve this, but it's just more of like it needs to be squared to be technically accurate here. Find the length and the width of the rectangle. So it also says that the length is 4 times the width. So if this is the width and this is the length is 4 times the width. So the area is 256 square units. The length is 4W, and the width is just W. And anytime you multiply something by itself, you can rewrite it using an exponent. W times W is W squared. So 256 is 4W squared. If we divide both sides by 4 here, I'm going to have to go to the calculator here. 256 divided by 4 is 64. So we get W squared is 64. We're going to take the square root of both sides. And we do get plus or minus the square root of 64. But again, it doesn't really make sense to have a negative width on this rectangle. So we are going to disregard that negative solution just because of the context of the problem. If it was just a straight up algebra problem, 256 equals 4W squared, yeah, negative root 64, that would be a solution. Now 64 is a perfect square, so we can simplify this. 8 squared is 64, so the square root of 64 is 8, and that's going to be our width. So the width is 8 units, and the length, which is 4 times the width, would be 4 times 8, or 32 units. And you could always double check that, 8 times 32, is that 256? Should be. I think it is. All right, one last type of equation that you're going to encounter that uses this square root strategy is one like the one on the next page, where it's not just the x that's being squared, but rather is an expression that's being squared. And so we're still going to approach this very similarly. The only real big difference here is we're going to try to isolate the squared object rather than just trying to get x squared by itself. You do not need to multiply this out or anything. Okay, first step you want to do is to divide both sides by 2. That's going to give me x minus 1 squared equals 25. And then now I've got that squared object by itself. So to get rid of that squared, this is where the square roots come in. I'm going to take the square root of both sides. So I have x minus 1 equals plus or minus the square root of 25, which is plus or minus 5. Now I can add 1 to this, but we have to be pretty careful about how we do this because we have essentially 2 equations right here. We've got x minus 1 equals positive 5 and x minus 1 equals negative 5. So when we add 1 to both sides, we're going to have to add 1 to not only 5, but also negative 5. So x will be 1 plus or minus 5. So we have to do 1 plus 5 and also a 1 minus 5. This is going to give us 2 different solutions that aren't just going to be plus minus. So 1 plus 5 would be 6, and 1 minus 5 is negative 4. So if your equation looks like this, just know that you're going to isolate the stuff that's in parentheses first, take the square root, and then deal with anything that's inside the parentheses last.